Hi, everyone. Can you all see the whiteboard?
Yes.
Okay. Okay, good. 10 is correct. Let's see. Neil, can you explain?
So it's saying that Blake, so they basically took 4 tests, and in those 4 tests, Blake scored a average of 78%. And it's basically telling all of the numbers that Jenny scored higher or lower than him. And so she scored in the first test that we don't know how much Blake scored, but she scored 10 points higher in the first test.
Mhm.
And then on the second test, 10 points lower.
Mm.
And in the third and fourth test, 20 points higher.
Mm.
So basically, I put all of those numbers into an equation. So since we didn't know the amount that Blake got in that he got on that exact test, so I just subbed in a variable for that. So I put B plus 10 plus B minus 10 plus B plus 20 plus B plus 20. And basically, after that, I added all of them together and subtracted the amount, and I got 4B plus 40. And if you divide that number by 4, you'll get B plus 10, which means that on an average, every test that Jenny scored was 10 points higher than how much Blake scored.
Good. Yep. So that is correct. Yeah. So the average of Jenny's is 10 points higher than Blake. I think generally this approach works well. The only one thing to be careful of is you don't know necessarily that Blake's scored the same on each of the 4 tests. So if we call all of these B, it kind of implies that, although it's kind of fine to assume that, because if Blake did score an average of 78, we could just essentially assume that each of the scores was 78. And actually, regardless of how Blake's average became 78, any 4 numbers that we pick that average to 78 to begin with, and we kind of follow this procedure, you'll get the same average for Jenny's test. So in that sense, it's okay to assume this, but maybe instead of actually picking them all as B, we could just say A is Blake's score on the first test, B is Blake's score on the second test, C is Blake's score on the third test, D on the fourth test. And what we'll see here is that it becomes A plus B plus C plus D here, plus 40 divided by 4. Now A plus B plus C plus D we know is the sum of Blake's tests. So divide that by 4 is Blake's average test plus 10. So that just becomes the same, 78 plus 10. But either way works here. But I think kind of maybe one more thing that you can think about more is just that we don't actually need to think about each test in particular. So if you want the difference between the averages, we can look at how did Jenny's score differ from Blake's on the first, second, third, and fourth, and kind of the total difference between the test scores divided by 4 must be the difference in the averages. So plus 10, minus 10, plus 20, plus 20, just adding these 4 numbers would give you plus 40. Divide that by 4 gives us this 10, which will be the difference between the 2 averages. Any questions on this? Okay, let's move to the second one. Okay, good. 3 is correct. Nidhi, can you explain?
Hi, so there are, so every edge can be touched by two sides. There's 6 sides on a cube, 6 divided by 2 is 3.
Okay, let's see. So let's draw out a quick cube. Okay, so maybe can you show me an example of in this cube, which edges you would kind of mark as a black?
Yeah, so let's see. Okay, I don't know if you can see that right there. That's an edge.
Okay.
And so now we know that upper cube and that the 2 cubes that it's touching. Can you see the cursor or no?
So if you want to show the cursor, you have to press spotlight, but you can draw, we can see the one that you've marked as black.
Okay. Anyway, so there's the 2 cubes that are touching there. You can do the same right there. And there are another 2 sides of the 6.
Mhm.
And then finally, right here for those 2 sides.
Good, perfect, yeah. Yeah, so good, yeah. As you said, first we can do 6 faces divided by each edge touches 2, but it's also good to see that we can find 3 kind of different edges that satisfy this. So you can imagine in some way, maybe the faces touched in a way where when I chose these 2, there were, or these 4, there was no edge that kind of only touched the other 2 or something like that. So I think this kind of helps us make sure that there is such a combination that works, but we see it can actually be better than 3, right? Because each edge touches at most 2 faces. We don't see any edge that an edge cannot touch any more than 2 faces. And we know there are 6 faces in a cube. So there must be at least 3 edges that are black. And we see that we can have exactly 3 by drawing it out and seeing that these 3 edges cover all these faces. So this edge covers this front face and the bottom. This edge covers the top and the right side. And this back edge covers these 2 faces. Any questions on this?
So what I taught actually was that it says what is the smallest number of black edges. So I thought that it was an edge, and each edge. Wait, can I annotate, please?
Yeah, sure.
So each edge was like, basically, I thought that this was an edge, but also known as a vertice, and that I thought that it would take up the vertice would take up all 3 of these sides. So once I just put one there, I also got all 3 of the sides. So I just thought that that's why I picked 2.
I see. Yeah, so I think typically when we are coloring the edges, the edge would only be kind of the line connecting 2 of the vertices. But I think this is maybe if we worded the question to ask something slightly different, which if you consider how many vertices do you pick that kind of touch all the faces, then your answer would be correct. So if you pick these 2 vertices, the vertices are adjacent to all 6 of the faces because this vertex touches 3 of the faces.
Thank you.
Mm-hmm. Any other questions? Okay, let's move to the last one. Okay, good. 76 is the answer. Nidhi, can you explain?
Nidhi is correct.
Oh, my bad. Okay, so I did a chart where I did 1, and then I wrote like the up till 3. So it would, in that row, it would be 1, 3, 9, 27, 81. And and then 2 would be 2, 6, 18, 54. And it was like a pattern. And I realized what we needed was something with mostly the large number with factors of 2, but then also it was more of a kind of process of elimination with this, which wasn't the smartest way to go about it. But I found the factors 2, 4, 19, and 38 worked there. So that's how I got 9. Well, not 30, the factors of. So that's how I got 76.
Okay, good. So you are correct on 76. And I think this approach is actually good to confirm that the 76 is the best we can do. But let's actually approach it a slightly different way to start off. And actually to do that, let's start off with how people got 67. So I think that's a common other answer. Maybe Ishan or Neil. Ishan, can you explain how you got 67?
I just thought it was like all the multiples of 3 between 1 and 100.
Same.
The non-multiples of 3, right?
Oh, I mean, I just subtracted the multiples of 3 from like 1 through 100. Like
Yeah, so
133.
Good,
So-
yeah.
I actually did basically the same thing. I just did the multiples of 3 and removed them off from 100 and just took the amount of numbers that were left that weren't multiples of 3.
Okay, good. Yeah, so this is one way that you can kind of start off. But so let's see kind of why this is, this doesn't kind of give us the best solution. So this is correct in that this is a set of numbers that don't have a member that is 3 times another, right? If I don't have any multiple of 3, there's no way for one of the numbers to be 3 times another number, right? So this is one way of avoiding it. But we don't know for sure that this is the largest, right? Maybe there's a different way of picking the numbers such that I kind of can allow this, right? And well, I can just show you an example with this set itself. So because we have the number 1, we can't have the number 3, right? But what about the number 9? Could we actually have included it in this set?
What was the question again?
Sure. So kind of both of the answers of 67, we're using this set, right? Which is all the numbers except multiples of 3. So we said 1, 2, we'll forget 3, 4, 5 don't include 6, 7, 8 don't include 9, and so on. So this is what you're telling me the answer should be 100 minus 33 is 67, right? So now we want to see why this is not the correct answer. So are there some multiples of 3 that we could actually add to the set without kind of violating the condition? So the first one that we looked at, 3, I can't actually include 3, right? The problem is if I include 3, what happens? I have both 3 and 1, and this is not allowed, right? Because my rule is I don't have one of the members being 3 times another. So this is not allowed. What about 6 and what about 9?
9 actually, there is no 3, so the 3 times 3, it can't be 9 because there is no 3.
Good. Yes. So in a sense, so it's not actually that we can't include any multiple of 3. We could still include some multiples of 3, but we have to be careful that we don't include, in a sense, in this table that Nidhi mentioned earlier, we don't want these consecutive ones next to each other to both be there, right? We can't have both 3 and 9, or we can't have both 9 and 27, but we could have 1 and 9, and we could even have 81 also. So that's kind of the reason why this doesn't cover all the numbers. Now, let's think about it in a slightly different way, which helps us get this answer of 76. Instead of thinking about removing all the multiples of 3, what is the number that I can include everything above it so without any issues? There's some threshold at which I could just say I'm going to include everything above this number. What is that number?
$33.
Good. Yeah. Actually, let's start with 34, because 33 is times 3 is 99. But if I look at 34, 34 times 3 is 102, right? That's above 100. I don't need to worry about that. So I could start off saying, instead of looking at non-multiples of 3, let's start with all numbers from 34 or higher, 34, 35, 36, 37, up to 100. Is this set allowed?
No.
Why not?
Because there'll be like, if you multiply by 3, then it'll be over 100.
Well, it will be over 100, but the rule is just that in this subset of numbers, is any of the members 3 times another? So can I pick two numbers between 34 and 100 such that one of the numbers is 3 times another of the numbers?
You can't.
No, right? Yeah, so this works. 34 to 100 satisfies this rule and picks all the numbers 34 and above. So now we have, how many numbers do we have here? From 34 to 100.
67.
66.
Yeah, 67 is correct because so 100 minus 34 is 66 plus 1 because we want to include both 34 and 100. So there's 67 numbers here. Now let's see what can we add to this. And let's start from the number 1. Could we add the number 1 to this set?
Yes.
Why?
Because there is no, like, you can't divide that number by 3 and get an even number, so 1 works.
Yep, because so if I think about it, 1 will not work if 3 times 1 was included, right? So right now we don't have a 3 in the set, so we're good. What about 2?
2 again works for the same reasoning.
Yep, 3?
3 does not work. 1 times 3.
Okay, 4?
4 works.
5?
Works.
6?
Does not work.
Good. 7?
Works.
Mhm.
8 works.
9?
And 10.
What
Oh,
about-
yes. 9 works too because there is no 3 to support the 9.
Yes. 10?
And then 10 works. 11 works. 12 does not work.
Why
No,
does
it
12
works.
not work?
It's a 4 right there, so it would work. 4 times 3 is equal to 12. Yeah, so 12 would not.
Good. So 12 doesn't work for 2 reasons. One is
Yeah,
4 times
because-
3 is 12, and another reason.
Because there's the 4 and 4 times 3 would be 12, and there should be no multiples of I meant the
Yep.
fractions of 3.
That is correct. Yes, 12. Okay, what about 13?
Yes, that works.
Careful, because we've already included the numbers 34 to 100.
Oh.
So
Oh
if
yeah,
you-
there's 39. Oh, so that can't work.
Yeah. And now this applies to any number above this, right? What about
Yeah.
14? 15? And if I go up to 33, same issue, right?
Mm-hmm.
So how many numbers do I have here?
9. Wait,
Plus,
9. Yeah, there's 9 numbers. 67 plus 9. 67 plus 9 is equal to 76.
good. Yeah, okay, so this is one way of maybe constructing the set a little bit more easily. You can imagine first just take all the larger numbers because there's no kind of issue here with like 34 times 3 is not included, 35 times 3 is not included, and so on. And then fill in the smaller numbers. And you do happen to get the actual kind of maximum here. But now let's go back and look at Nidhi's original method let's kind of try to prove here why 76 is actually the maximum. I think this shows us a set that can be made with 76 numbers, but it doesn't fully convince us that maybe there's no other way of choosing the numbers where there's 78 or 79. So let's go back now to this kind of table. And the idea here is that we want to look at what are the possible numbers that may overlap. So for instance, if I have the 1, then I won't be able to have a 3. But if I have a 3, I won't be able to have a 9. If I have a 9, I won't be having a 27. If I have a 27, I can't have an 81, and so on. So these are the numbers that essentially will only affect each other, right? So if I have any of these 5 numbers, they could affect the other numbers in this, but they don't kind of affect any other numbers, right? So if I have a 9, I could also have a 29 or something like that, because there's no kind of multiple of 3 that could multiply between those two. So let's group the numbers from 1 to 99 in this way. So 1, 3, 9, 27, 81 are one group. 2, 6, 18, 54 are one group. Now 3 is already grouped. So the next would be 4, 12, 36, 5, 15, 45, 6, or 6 is already there, sorry, 7, 21, 63, 8, 24, 72. 9 is already there. So I'm going to fill in a few more here so that we're until we reach, yep. What's the next row here?
10, 24, 72. Oh, wait, sorry. 10, 30, 90.
Next.
11, 33, 99.
Good.
And then 12. No, 12. Wait, yeah, no 12. Because there's, yeah.
What's
13, 39. And that's it. 13, 39. Oh.
Okay, well, we could keep going, right? So 14.
Yeah. 14, 42. And 15, 45. 16, 48.
1545 is already covered, right? With 5, 15, 45. So we only essentially the first number in this should only be not a multiple of 3. So 16, 48.
48.
17.
19. 51.
Okay, 18.
18. 54. 19.
57.
Good. Oh, sorry, 1854 should also not be there. We already have that covered with 6. Yeah, 19, then what?
20, 60.
Okay, next.
163.
Careful.
22,
21 be there?
22, 66.
Next.
23, 69. 24. Oh no, there's already a 24.
Good.
25, 75. 26 is there, no, 26, 78.
Good.
27. Wait, there is already a 27, my bad. 28. 28.
84.
Good. Next.
29. 87.
Good. Yeah. Next. So we'll stop in a little bit. I just want a few more rows.
Oh, 31,
92.
91.
93. Good. Next.
32. 96.
Good.
30,
What's the next row?
there is no more.
So 33 is already there, right? But what about the next number?
34, but then that'll cross 100.
Okay, so it's just 34 then, right? So
Yeah.
the interesting thing here is 34 doesn't affect any other number, right? Because
Yeah.
divided by 3, it's not a multiple of 3. Multiply it by 3, it's more than 100. So that's actually only a single number in the row. What is the next number?
$35.
Okay.
That's it.
And then next.
37.
Good. Okay, so I'm not going to fill the rest in, but it's basically all the non-multiples of 3 at this point up to, what's the last number?
98.
Okay, 98 is
100.
there. What's after that? Yeah, 100.
100.
Okay, good. So now we have the full table. At the end, these are all going to be single numbers. Now let's go back and see, okay, what is the maximum number we can take in each group? So let's start from the bottom. Those are the easier ones.
1.
So start from 100, we can take it. If we include it in the set, this doesn't limit us from taking any other numbers. If we take 98, this doesn't limit us. Up to, we can take 34 and not be limited in any way.
Yeah.
This makes sense?
Yes.
Okay. So how many numbers are in this part?
There are five. Oh, 67.
Close.
You say
59.
Why 59?
I think 98 minus 37.
Close. Okay, so we're taking all the numbers between 34 and 100, but we're skipping some of them. Which ones are we skipping? So we skipped 36 here, right? We would skip what else after this?
Oh, yes. And you're also
We would skip 39, 42, 45.
Or
all the multiples. You'd skip all the multiples of 3.
Okay, so how many numbers are there between 34 and 100, not including multiples of 3? Another way you could do this is you could count all the numbers from here to here and subtract that from 100. This will give you the same answer. Someone can try that way and double check, but either way, what would this number be?
$44.
Okay, good. Let's double check. So what is the total number of numbers we already know from 34 to 100 is 67 numbers, right? Now, how many multiples of 3 are there? So this would be, let's see, 33 minus 11, 22, right? So from 12 to 33 times 3. So this gives us 45. Does this make sense?
Yes.
Okay, now another way you can do it is let's actually count. So 5 here plus 4, 9, 12, 15, 18, 21, 22, 25, 27, 29, 31, 33, 39, 41, 43, 45, 47, 49, so on. And you can double check that you should have the remainder of this. Okay, so now we have this part. Let's now look at these, 32 and 96. What is the maximum number from this set that I could choose?
$96.
Or sorry, what is the, like, could I include both of these or do I only include one? Is it possible to include both of these in one set?
No.
No.
Good,
You
why
can
not?
only do 32 because 96 is a multiple of 3.
Okay, or I could actually only do 96, but not include 32, right? Would that also work?
Yes.
Okay, so actually this is kind of related to this set, right? Because in this set, which one of the two did I include?
$36.
Okay, of 32 or 96?
96.
So in this set, I included 96, but I didn't include 32, right?
Yes, you did.
Okay, so that means one of these two is allowed. But if I include a 32, I can't have 96. If I include 96, I can't have a 32. So I'm allowed to take one from this set. Now let's do the same thing with 31 and 93. What's the maximum I can take from this set?
93.
93.
Okay, yeah, basically one of them I can take, one I have to remove. So the same thing applies to all of these with 2, right? So what is the maximum I can take from here? From 1339, 1442, 1648, and so on.
Can you repeat the question?
Sure. So if I take one from this 13 or 39, one from 14 or 42, one from 16 or 48, how many total numbers can I choose from these kind of pairs that I have here?
14.
Good. 14. Okay, so I know I can pick 45 from the singles, 14 from the pairs. Now let's move to the triples. What's the maximum I can choose from this 11, 33, or 99? The maximum number of numbers, not.
1.
Okay, so one, I could choose just 33. Is it possible to choose two of these?
Yes.
Which two?
11 and 99.
Okay, good. And why is that possible?
Because they are not multiple. Because they are multiples of 3. They're not.
Yeah, so they're not multiples of 3 of each other, right? So 11 times 3 is 33. 33 is not in my set. And if I look at 99, 99 divided by 3 is 33. That's also not in my set. So I'm good, right? 11 is included and 99 is included. So yeah, I can take two of these. What about this 10, 30, 90?
You could take the 2, the same.
Same thing, right? I can take 10 and I
Same
can
logic
take
for
90.
last time.
Good. Okay, so if I apply the same logic to these, how many could I get for all the?
2. 12.
Good. 12. So this is, we have 6 times 2 is 12. Okay, now let's do those last two. So we have one of them with 4, 2, 6, 18, and 54. How many of these can I take?
2.
Why 2?
3. No. 3.
Okay, which 3?
Never mind. I'm sorry. It's 2 and 54.
Okay, yeah, so you could actually take any pair of these. So you could take 218, 254, 654. Any of these would actually work. The problem is I can't take two that are next to each other, right? When I'm looking at this table, if I take 6 and 18, that's a problem because one is 3 times the other. So essentially the question is, in a row, how can I pick, what's the maximum I can pick without picking two that are next to each other? So in this case, I can't pick 3 with having two that are not next to each other. So I can pick at most 2 from here. Okay, so this gives me an additional 2. What about the first row?
You can at most pick 3, 1, 9, and 81.
Good. So here we can pick 1, 9, and 81. Again, the same idea, right? We don't want to have any two that are next to each other. So we don't want 1, 3. We don't want 9, 27. So this gives us 3 more here. So what does that give us to total?
$76.
Good.
You
So
add them.
3 plus 2 plus 12 plus 14 plus 45. Okay, so now are we sure that 76 is the maximum?
Yes.
Yes. Okay, yes. And the reason is because now we've grouped it this way, we know for sure that in these pairs, if I took one of them, I had to remove the other one, right? So I know in each of these sets that this is the minimum number I can remove because from each of the pairs, I had to remove 1. From each of the triples, I had to remove 1. And from these 4 and 5, I had to remove 2 and 3, or 2 on each of these. So I know that's the minimum numbers I have to remove to still maintain this property. So by kind of grouping it in this way, I can confirm this, but you can also kind of generate the set in this way as well. And kind of find a set of numbers that actually have 76 total. Any questions on this?
No.
Okay.
There's no questions.
So an interesting extension to this is how many sets are there with 76 elements that satisfy this property? But we can kind of keep this as an extension for next week, but you can think about this using this diagram. Can we actually figure out how many sets there are that satisfy this property? So where this is one of such sets. Okay, any other questions? Okay, that's it for today's class then. We'll see you all next week.
Thank you.
Thank you.
Thank you.
Bye. Thank you.
Bye.